All right, on page 390, we have one more question to go over. Good practice for us. We've been trying to figure out where an angle is located, like in which quadrant or on which axis. And if we can figure out where an angle is located, we could possibly figure out what the other trig values are for that particular angle. So we're going to finish or wrap one up today before we start the next section, which is going to utilize the calculator that you need. So on page 390, we know the tangent value for some angle is -4/3, and the secant value for some angle is just positive, something greater than 0. Based off those two pieces, we only want to find the cosecant value and the cosine value. We could figure out all the trig values like we did for previous problems, but for this one, we're just going to focus on those two. So let's try to narrow down which quadrant this angle might be located in based off the information that they give us. So we know a tangent value. How is tangent related to the unit circle in terms of those variables x and y? Yeah? That'd be cotangent. Y over x. All right, so tangent is y over x. We need that fraction to be negative, because notice how the tangent ratio was negative. So if that fraction has to be negative, what do we know about the variables? How can you make a fraction negative? Yeah. One of them is negative. Okay, so one of the variables is negative. That's all we really know at this point. We can't really conclude which one is negative. We just know that one of them is negative. All right, so let's see if we can use this other one to kind of narrow it down even more. How is secant related to x or y on the unit circle? Yeah? The adjacent, so it's the reciprocal of cosine, right? And how is cosine related to x or y on the unit circle? Yeah? It would be the reciprocal of x. Good. So 1 over x. We want this fraction to be positive, okay, greater than 0. So the only variable in that fraction is the x. So x is positive. Can we now deduce what the y variable would be? If we take a look at our two statements. Yeah? Y would have to be negative, okay, because we said over here one of the variables has to be negative. So x is positive, and bless you, y is negative. All right, so if we have a positive x and a negative y, can we determine which quadrant this angle theta is located in? Yeah? Quadrant 4. All right, let's go ahead and draw quadrant 4. With some angle in that quadrant. You can draw the angle wherever you want. Yesterday, the one at the top of the page that we did, the angle was in a specific spot because it was along a line, but we don't know that information for this one. So you can draw any angle you want as long as it's in quadrant 4. We'll go ahead and label that reference angle as theta, and we can form our reference triangle, which will have one of the legs on the x-axis. Somehow we should be able to label all 3 of those sides to help us figure out our trig values. So we're going to go back and utilize the tangent fraction they gave us to help us label some of the sides. So one of those sides we can label as 4, another side we can label as 3. One of them is going to get a negative sign. The question is, where does the 4 go, where does the 3 go, and which one gets a negative? So can we think about tangent, how it's related to SOHCAHTOA? Where would the 4 be located? Where can we put the 3? What do you think, Ashlyn? Go ahead. All right, so tangent is opposite over adjacent. So in relation to our reference angle theta, the opposite side we could label as 4. The adjacent side would be 3. When we take a look at those sides, notice how the 4 side is the negative one. It goes down, so that would have to have the negative sign in front of it. I like it. Can we figure out the hypotenuse? That third side? Yeah? Pythagorean theorem. All right, let's go ahead and do it. So 3 squared.
At this time, we need group number 1, the 8 to 9:15 group, to report to the audion. Group number 1 to the audion, please.
All right, we'll get c squared is 25. So c, our hypotenuse, would be 5. Now that we have all 3 sides labeled, we could figure out all trig values if we wanted to, but again, they only want us to figure out those 2. So let's see if we can figure out cosecant ratio and that cosine ratio. Think about SOHCAHTOA. We're dealing with a right triangle. Any thoughts? Let's see, maybe we'll write down the relationships. Cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, we would need hypotenuse over opposite. So in our little diagram there, go ahead, Marie. Say it again. That's what sine is, because that would be opposite over hypotenuse. We just need to flip it. There we go, -5 over 4. So we'd have 5 over -4. You can move the negative to wherever you want in that fraction. All right, there's our cosecant value. Cosine, SOHCAHTOA, we need adjacent over hypotenuse. Yeah, 3/5. Perfect. We still have it from yesterday? We can figure out where an angle is located in a quadrant. We can draw that angle, we can make a triangle, we can find all the sides, we can find all the trig values. All right. We're going to do some things very similar today. We're going to utilize this reference triangle concept to help us solve trig equations. So just like you use algebra to help you solve like regular x and y equations, we're going to utilize algebra skills again to help us solve trig equations. So they're a little bit different because we're working with trig values or trig functions, but it's still an algebra process nonetheless. So we're going to go ahead and start the next section on 393. And just like I try to do, because this is going to be fairly new to us, I wrote down some steps to help us out, but realize those steps are not going to be there all the time. Okay, they're just kind of a guiding process for us to get used to solving these trig equations. We're not going to use a calculator for this one. Okay, we will for some other ones. So we're going to try to do this one kind of in our heads. Now, in order for us to solve a trig equation without a calculator, that means this equation should be fairly easy or simple to solve. And if that's the case, that means we're going to utilize the unit circle to help us with this particular problem. because on the unit circle we have all of those values and radians and ordered pairs that we are already familiar with. If we are going to use a calculator, that means we might get some crazy number, okay, because it's not on the unit circle, but we can still solve it nonetheless. Okay, so I wonder if I state it in here. Maybe at one point I do. Let's go ahead. We're not going to draw the whole unit circle. I just want to go ahead and reference the first quadrant, because if we know that first quadrant, we can use patterns or symmetry to help us figure out the rest of it. Okay, so the first quadrant is key in this unit circle. So somewhere at the top, let's go ahead and draw in our first quadrant. And we normally have angles 0, 30, 45, 60, and 90. If we were to convert those to radians, okay, what would those look like? Are we familiar with some of these by now? Do we know what 90 is as a radian? What's at the very top of our unit circle? If you think about a whole circle as 2 pi, right, and you only go one quadrant, aka a quarter of 2 pi, can we think in terms of fractions? Yeah? Pi over 2. All right. 45 is halfway to that 90-degree point. So this would be half of pi over 2, so that'd be pi over 4. Can we fill in the 30 and the 60? Maybe we can convert those real quick in our head, or you might know them off the top of your head. They're going to have pi's in them. We got to know this first quadrant. All right, 30 degrees is pi over 6. And if 60 is double 30, we could double pi over 6, and that would give us pi over 3. All right, we got to know that first quadrant. What also we have to know in the first quadrant are the ordered pairs that go along with those points. So I kind of ran out of room over here, but we'll go ahead and write them on this side. What was the ordered pair at the 0-degree point? Okay, that initial point or starting point that we have on the unit circle? Yeah? 1, 0. Yep, you go out 1 unit, but you don't go up or down at all. Let's see, we also want to tackle 45, 60, and 90. Okay. Maybe we'll do 9, or you want to do another one, Marie? Go ahead. 9 is 0, 1. All right, and then the 30, the 45, and the 60 are those crazy ones in the middle. We took the time to develop those using triangles. You're either going to have a 1/2, a square root of 2 over 2, or a square root of 3 over 3. Or sorry, square root of 3 over 2. You only have those 3 options. Can we think about what would go where? We got to know these. All right, at the 30-degree mark, we have the square root of 3 over 2, comma, a half. The 60-degree mark is the same numbers, just switched. And the 45 is the square root of 2 over 2 for both of them. All right, we got to know those. Once we know that first quadrant, we can use the symmetry or folding concepts to help us fill in the rest. Okay, but the first quadrant is key. We got to know it. So we're going to utilize that first quadrant to help us solve this trig value, okay, without a calculator. So first thing we're going to try to do, just because our brains are geared towards sine, cosine, and tangent, those are the first trig functions you ever learned, we're going to try to rewrite this trig function, if necessary, okay, in terms of sine, cosine, or tangent. So can we think about how secant is related to sine, cosine, or tangent? It's the reciprocal of one of those. Which one is it the reciprocal of? Yeah? Cosine. All right, so this side we'll write as 1 over cosine of theta. Now, I don't really want the cosine in the denominator of that fraction. Okay, I want it in the top. So we're going to do a little flipperoo here. If I find the reciprocal of this side, that must mean I have to find the reciprocal of the other side, right? Algebra steps, what you do to one side, you do to the other. So if I flip this side, it would turn into cosine of theta. And if I flip the other side, we would now have 3 over 2 square roots of 3. But I have a square root in the denominator. If we were to get rid of it, okay, multiply by a square root of 3 up top and a square root of 3 down below, we'd have 3 square roots of 3 over 2 times 3, because that square root of 3 would eventually go away and you'd just be left with a 3. Do you notice anything that's going to happen? Can we simplify that fraction even more? Notice, yeah. There we go. The 3's would cancel out. Perfect. All right, so in the end, we have cosine of theta equals the square root of 3 over 2. Instead of that crazy secant fraction we started with, now we have something a little bit nicer, because notice how the square root of 3 over 2 is some special point on our unit circle, right? We didn't have 2 square roots of 3 over 3 listed as any of these ordered pairs. So that's why we want to change it into sine, cosine, or tangent, because we might be able to utilize the points on the unit circle. All right? So based off of this value, we should be able to figure out where the angle is located, like in which possible quadrants this angle might be in. So if the cosine value is a positive square root of 3 over 2, where might we be located? What variable does cosine represent again on our unit circle? Yeah? All right, so the x is positive, because notice how we had a positive square root of 3 over 2. So which quadrants is this angle located in? Where is x positive? Yeah? Quadrant 1 or quadrant 4. Good. All right, so we're narrowing down where this angle is located. Which angles, okay, on the unit circle have a cosine value of the square root of 3 over 2? That's what we're trying to figure out. Okay, where on the unit circle is the x-coordinate square root of 3 over 2? Now, we could simply look at a unit circle to figure it out, but we're going to try to just use the first quadrant that we have to know to help us figure that out, because we might not always have a unit circle at our disposal. Okay, we should know the first quadrant. So, let's go ahead and take a look at this. This is our rewritten equation. Cosine of theta equals the square root of 3 over 2. We want to figure out what theta is, so how would we move the cosine to the other side? We did this at the very beginning of the unit when we were solving all those triangles. Yeah? The cosine inverse, yep, or the -1 power. Good. All right, now you could type that in on your calculator, but again, we're trying to do this without a calculator. Let's see if we can figure this out. Okay, on the unit circle, and notice how at the top we're going to work in degrees. On the unit circle, where does cosine have a value of the square root of 3 over 2? Look at the ordered pairs we had to know. Which one has an x value of a square root of 3 over 2? Yes? 30 degrees. Okay, right there. Notice how we had an x value of square root of 3 over 2. So one of our angles is 30 degrees. But we said that this angle could be in quadrant 1 or quadrant 4. Okay, maybe there's another angle that would also have that same cosine value. This is when we're going to utilize a graph to kind of help us figure that out. Let's go ahead and draw an x and a y. And we stated that an angle could be in quadrant 1 or quadrant 4. So we're just going to go ahead and draw an angle in either one of those quadrants. Which one of those angles that I drew in is the 30-degree angle? The one in quadrant 1 or quadrant 4? Yeah? There we go. So this is our 30-degree angle. Notice how that would be our reference angle of 30 degrees. Somehow, we need to figure out what this other angle is in quadrant 4. Now, if you think about quadrant 4 in terms of your degrees, it's going to be something between 270 and 360. Okay, somewhere in that fourth quadrant. So we're going to utilize our reference angle to help us figure that out. Instead of going 30 degrees up from the x-axis to land in quadrant 1, we're going to go 30 degrees down from the y-axis so that we land in quadrant 4. These angles are related to each other. They're going to have the same reference angle, they just land in a different quadrant. Okay, they're not coterminal, even though they have the same reference angle, they're not landing in the same spot. So if you were to go 30 degrees down or backwards, can we think about what angle we would have in that case? It has to be something between 270 and 360 if we're in quadrant 4. What do you think, Marie? Yeah. 330. There we go. All right, so our secant value, this particular theta measurement, we would say is 30 degrees or 330 degrees. All right, and I'll show you why we got the correct answer, okay? I'm going to throw in a whole unit circle for a second. So if you look in quadrant 1 and quadrant 4, okay, we're looking for an x value of the square root of 3 over 2. Notice how that happened at 30 degrees like we said it should. And if we look at 330 in quadrant 4, it has the same positive square root of 3 over 2. So when we're solving these trig values, you may get two answers. Because using that symmetry idea we talked about for the first quadrant, you may end up with the same x values. Sometimes you might have the same y values, like a half and a half. So you might get two answers for a lot of these questions. Okay, the tricky part is trying to figure out which quadrants you're located in, and that's why we spent so much time doing that. Okay, so if we can figure out which quadrants we're in, we're going to have an easy time from there. All right, let's see if we can do a similar one, this time without the steps kind of broken down for us. You can reference them at the top if you want to. All right, so use the plan above if we have to help us figure out this angle measurement. It's already a sine, cosine, or tangent, so we don't have to worry about rewriting it, okay, because we're already kind of familiar with sine. Let's try to figure out which quadrants we're located in. Which variable does sine represent on our unit circle? Yeah. Y. All right, so y is negative. Notice how our sine value is negative. So which quadrants are we located in if our y value is negative? Yeah. 3 and 4. Okay, so immediately, as soon as we know that, I'm going to go ahead and draw a graph with an angle in quadrant 3 and quadrant 4. I know I should have two answers because y is negative in two spots. Okay, so we need to figure out what these angles might be. Again, this is when we're going to utilize the first quadrant to help us out. We need a y value of a square root of 3 over 2. I don't care if it's negative just yet, okay? Just a square root of 3 over 2. So take a look at the points that we did at the very top. Of those in the first quadrant, which one has a y value of the square root of 3 over 2? Yes. Say it again. The y value is a half. It's okay. 60 degrees, right? Okay, so our reference angle for both of these is 60 degrees. Reference angle is the closest x-axis. So that's not necessarily our answer like it was in the previous one, because we said it was 30 degrees and one of the answers was 30. This time our reference angle is just 60 degrees. So we got to utilize that reference angle to help us figure out these two angles. One of them's in the third quadrant, something between 180 and 270, and the other one is something between 270 or 360. Can we figure out those two measurements? What might this angle theta be? What do you think, Rebecca? Yeah?
The triangle is 300.
300? All right, so that would be this one. How'd you get 300?
Just subtracted 60 from 360.
There you go. If this is 360, if you were to do a full circle, you'd land there. You want to go backwards 60 degrees, so that would give you 300 degrees. What about the other one? Go, Rebecca.
That one's 240. Usually we add 60 to 180.
You'll get 240. All right, so our two answers will have 240 degrees and 300 degrees. We did that without a unit circle because we just used the first quadrant at the top that we wrote down. But if you wanted to check your work, you could use a unit circle. Let's go ahead and check out quadrants 3 and 4. So we're somewhere down here. And we want a y value of the negative square root of 3 over 2. Notice how that happens right here, which has an angle of 240. And that also happens right here, which has an angle of 300. So you can double check your work on the unit circle, but we're trying to do it without one, just so we get comfortable with that first quadrant. We're doing okay so far? I hope. Okay, we're going to try some ones that are going to need a calculator. So notice how these values, instead of being a square root of 3 over 2 or a 1/2, something that we know is on the unit circle, these are now decimals. So we're going to have to utilize our calculator to help us with those. Okay, we're still working in degrees, so if we're going to utilize our calculator, make sure you are in degree mode. Okay, so take the time to go ahead and check that. All right, let's first try to figure out which quadrants we might be in. Notice how our sine of theta is a positive number. So where can I draw my angles in a grid? If sine is positive, which quadrants are we located in? Think about which variable sine represents. Let's see, sine's a y value, so y would be positive in quadrant 1 and quadrant 2. Okay, we're going to draw in our angles there. We need to figure out what are these reference angles. Okay, that way we can utilize those to help us figure out the exact angle measurements. So if we're going to utilize our calculator, we have to move the sine function over, which would need a sine to the negative first. All right, so if we were to type that into our calculator, what would we get? Did we get 47.307? That sound about right? Okay? Which quadrant is that 47-degree value located in? Are we in quadrant 1 or quadrant 2? Yeah. Quadrant 1, right? Because it goes 0 degrees and then 90 degrees is the very top. So this reference angle is 47.307 degrees. That means the other reference angle is the same, 47.307 degrees. So we should be able to figure out what these two angle measurements are. Let's see, the one in the first quadrant is just going to be that 47.307 degrees. How can we figure out the other one, though, in quadrant 2? What do you think, Marie?
Subtract the 47 from 90.
If you subtract
180.
180, right. So this is 180 on the very left-hand side. We want to go backwards, aka subtract 47.307 degrees. So 180 minus that, we would get 132.693. There are our two solutions. All right. Now, since we have a calculator, we should be able to check our work. Let's see what that would look like. Bless you. On your calculator, you can type in sine of 47.307. Notice how we get something really close to 0.735, which is really good. And then let's go ahead and check the other one, the one that we actually had to figure out, the one the calculator didn't give us. We'd type in sine of 132.693, and notice how we get the same exact decimal. Okay, so your calculator is only going to give you one of the angles. When we typed it in, it only gave us the 47 number, right? It's up to us to figure out the other one, because according to the unit circle, there most likely should be two spots where you can have that angle measurement, or that sine ratio to be 0.735. Okay, so your calculator can only do much. Your brain can do more. All right, let's see if we can at least start the next one. We want a cosine value to be negative. If cosine is negative, which quadrants are we in? 2 and 3, right? Cosine is an x value, x is negative in 2 and 3. So we'll immediately draw those in. Let's go ahead and in the equation, we'll move the cosine over. And we'll see what the calculator gives us. Do we get about 118? Okay. If we have a 118 degree angle, is that the one in quadrant 2 or quadrant 3? Yeah? Quadrant 2. All right, so this whole angle right here is 118.816 degrees. Notice how that angle is not a reference angle, because a reference angle is acute, something less than 90. So let's go ahead and think about if instead of trying to travel 118 degrees forwards, what if we were to travel 118 degrees backwards? Wouldn't that land us in quadrant 3? How can we figure out that other angle or degree measurement? Yeah. From 360, right? So 360, if you were to do a full circle, we'll go backwards 118 degrees. So we would get 241.184 degrees. We can double check our work. All right, so on our calculator, we can type in cosine of 118.816. Notice how we get negative 0.482 if we were to round it. So we know that first angle is correct. We can also double check the one that we had to find, okay, the one the calculator didn't give us. Cosine of 241.184. Notice how we get the same thing, okay? So your calculator will give you one, it's up to you to find the other. Are we doing okay? We'll finish that up tomorrow, all right? Just more examples, more practice, but I think we're doing good.